Namaskaram everyone. Welcome back for another interesting session of Mathematics 1B. Students, you have already learned about straight lines, various forms of straight lines, the angle between the straight lines, and you have also practiced many questions, problems that were given in the chapter straight lines. After that, you've also started with pair of straight lines in our earlier session. In the first lesson, we've discussed about the combined equation of a pair of straight lines, the angle between the pair of straight lines, and what is the condition for the pair of straight lines to be perpendicular. We have focused on the homogeneous equation ax square plus 2hxy plus by square is equal to 0. To be representing a pair of straight lines, the condition was, it's an if and if only if condition, h square should be greater than or equal to ab. Is it not? Hope you can recollect all that, and I'm sure you have practiced all the questions given, and now we are ready with another interesting concept in pair of straight lines, that is concept of bisectors of angles between the pair of straight lines. When you take any pair of straight lines, either they are parallel, perpendicular, or intersecting. When they intersect, if the angle between them is 90 degrees, we call them perpendicular lines. If the angle between them is not 90, it can be either an acute angle or an obtuse angle. What does that mean? When two lines intersect, there will be four angles formed. Two pairs of equal angles which are vertically opposite angles. Out of those two, one will be acute angle, the other will be obtuse angle if they are not perpendicular. Is it not? Yes, you all know about it. So when we draw bisectors of those angles between the straight lines, the angle bisectors take some equation form. What is the form of those equations? And how do we find the equations when independently you are taking two straight lines, or when you're taking a pair of straight lines which form the angle bisectors? These are the concepts that sir is going to take today. You're already familiar with Mr. K.SRINIVAS garu. Sir, I'm so happy to welcome you again. Sir is a PGT Mathematics from TSMS Ambam, Varni, Nizamabad district. Sir is here to take up pair of straight lines, the concepts on angle bisectors, and also general form of equation of a pair of straight lines, and as well the product of the perpendicular distances from a point to a given pair of straight lines. Srinivas garu.
Thank you, madam.
Over to you, sir.
Thank you, madam. Thank you very much.
Please continue with the session.
Okay. Good morning, all. Welcome to today's Mathematics 1B Pair of Straight Lines webinar session. Good morning, students. In the previous session, we have discussed regarding that combined equation of two straight lines, second degree homogeneous equation, and second degree general equation in that x and y terms, x and y variables. Again, we have discussed one more theorem regarding that the equation of the pair of straight lines ax square plus 2hxy plus by square equal to 0, that is passing through the origin if and only if h square greater than or equals to ab. And we have discussed regarding that the angle between two straight lines and angle between given pair of straight lines. Again, we got that the condition from the angle between given two pair of straight lines, we concluded and we obtained one more condition. That is, we got the condition that the if those two pair of straight lines are perpendicular each other, then what will be the condition? So we got one more condition also. So those are discussed in the previous session, and so I think that you are all of you have completed the work given by us. That is, some problems are given. I think that you have all are got the answers. So let us start today's. We are going to discuss that is bisectors of angles between two straight lines and pair of bisectors of the angles between a pair of straight lines and product of the perpendicular distances. Lastly, area of the triangle, and some problems will be discussed today. So let us go for that bisectors of the angles between two straight lines. As just Madam has told that, so if any two straight lines are perpendicular to each other, so therefore that angle between those two straight lines will be 90 degrees only. If they are intersecting, and if the angle between them is not 90 degrees, then we will get the two type of angles between them. So first one is obtuse angle and second one is acute angle. So here the larger angle is called that obtuse angle and that smaller angle is called the acute angle. So here let us discuss about the bisectors of the angles between given two intersecting lines. So let the equations of two intersecting lines be L1 equals to A1x plus B1y plus C1 equal to 0 and L2 equal to A2x plus B2y plus C2 equal to 0. Then the equations of bisectors of the angles between the straight lines L1 equal to 0 and L2 equal to 0 are A1x plus B1y plus C1 by under root of A1 square plus B1 square equals to plus or minus A2x plus B2y plus C2 by under root of A2 square plus B2 square. So here in our diagram, so those two straight lines are intersecting each other, and that so in between them we will get the two types of angles. So first one is larger angle, that is called that obtuse angle, and second one is acute angle. So here, and two more straight lines are there. So here blue lines are there, those are called the angle bisectors or bisectors of angles. So these two are bisecting the angles between given two straight lines. So these two lines are, first one is acute angle bisector and second one is obtuse angle bisector. So let us prove the theorem here. So here let P x1 comma y1 be any point on the angle bisector. So L1 equals to A1x plus B1y plus C1 equal to 0. L2 equal to A2x plus B2y plus C2 equal to 0. So here suppose P x1 comma y1 is any point on any one of the angle bisectors of these two bisectors. So here according to the diagram, that is P is there. So P is on the angle bisector. So suppose here, so this line is called the acute angle bisector. So here this angle is lesser than that or smaller than that of this bigger value. So therefore, so P is a point on the acute angle bisector. Let us take one point P on any one of the angle bisectors. So from that P point, I am taking the two perpendicular distances, perpendiculars. So free P to that. So this is first line and this is second line. I am taking that P to that first line is M, PM, and P to that second line is PN. So let us take the two perpendicular lines or perpendicular distances from the point P to these two lines. So we know that condition. Suppose any point on the perpendicular bisector of any two straight lines, then the distances from the point P to these two lines will be equal. So that's why here also, according to that condition, the PM and PN will be the equal. So here we are using that formula, perpendicular distance or length of the perpendicular from the previous chapter. Suppose P x1 comma y1 is a point on the a point in the point in the plane, and ax plus by plus c equal to 0 is a straight line, then we know the length of the perpendicular from the point P to that straight line is given by modulus of ax1 plus by1 plus c by under root of a square plus b square. So here also we are equating that pm and pn distances are equal. So those are drawn from the point P to that given two straight lines. So therefore we can use the condition Pm equals to Pn here. So we have to use that formula while finding that Pm and Pn. Yes, so that is nothing but that is the lengths of the perpendiculars from the point P to that first straight line, as well as that Pn is P to that second straight line. So we are equating that is Pm equals to Pn. So therefore, Pm nothing but modulus of a1x1 plus b1y1 plus c1 by under root of a1 square plus b1 square. Similarly, Pn equals to modulus of a2x plus b2y plus b2y1 plus c2 by under root of a2 square plus b2 square. So we got that. So modulus of x equals to modulus of y form. So here to remove this modulus symbol, we have to do one thing, that is taking that plus or minus symbol to that right hand side. So we can write that is, so by removing this modulus symbol, that is a1x1 plus b1y1 plus c1 by under root of a1 square plus b1 square equals to plus or minus a2x1 plus b2y1 plus c2 by under root of a2 square plus b2 square. So therefore we got two equations. What are those? By taking that plus symbol, we will get one equation of the angle bisector, and by taking that second symbol, we will get that equation of the second bisector. So therefore, the locus of the point P x1 comma y1 is, that is a1x plus b1y plus c1 by under root of a1 square plus b1 square equals to plus or minus a2x plus b2y plus c2 by under root of a2 square plus b2 square. So therefore we got that. So therefore the equations of the angle bisectors of the angles between the given two straight lines a1x plus b1y plus c1 by equals to, sorry, a1x plus b1y plus c1 equals 0, and that a2x plus b2y plus c2 equals 0. These two are the given two straight lines. Now we got the pair, that is angle bisectors, or bisectors of angles between given two straight lines are a1x plus b1y plus c1 by under root of a1 square plus b1 square equals to plus or minus a2x plus b2y plus c2 by under root of a2 square plus b2 square. Now by using this formula, now we are going to find out the angle, or find out the equation of the angle bisectors between the given straight lines, individual straight lines. So here we have to find out the equations of angle bisectors, or bisectors of the angle between the given two straight lines 7x plus y plus 3 equal to 0 and x minus y plus 1 equal to 0 by using that previous theorem. So here given the equations of the straight lines are 7x plus y plus 3 equal to 0 and x minus y plus 1 equal to 0. Now we have to compare these two straight lines with our equations. So this 7x plus y plus 3 is in the form of a1x plus b1y plus c1 equal to 0, and that this is x minus y plus 1 equal to 0 is of the form of a2x plus b2y plus c2 equal to 0. Now we have the formula, that is equations of bisectors of the angles between the given two straight lines. L1 equals to a1x plus b1y plus c1 equal to 0, and L2 equal to a2x plus b2y plus c2 equal to 0 are given by a1x plus b1y plus c1 by under root of a1 square plus b1 square equals to plus or minus a2x plus b2y plus c2 by under root of a2 square plus b2 square. By using this formula we have to find out the equations of the angle bisectors of given two straight lines, that is 7x plus y plus 3 equal to 0 and as well as that x minus y plus 1 equal to 0. First of all, we have to compare the given equation from given equations 7x plus y plus 3 equal to 0 and that x minus y plus 1 equal to 0. We have to compare these two straight lines, these two equations with the equations a1x plus b1y plus c1 equal to 0 and that a2x plus b2y plus c2 equal to 0. So this is first line and this is second line. So therefore, by comparing both the set of straight lines, that is here in case of a1, 7 is there, a1 equal to 7 and that b1 equal to 1, c1 equal to 3 and here a2 equals to plus 1, here b2 equals to minus 1 and c2 equals to plus 1. Now we have to note down all these values. So therefore, now we have to substitute all these 6 values in our formula. That is, the equations of the angle bisectors are a1x plus b1y plus c1 by under root of a1 square plus b1 square equals to plus or minus a2x plus b2y plus c2 by under root of a2 square plus b2 square. After substituting all these 6 values in the formula, so we will get that in the left hand side, that is a1x, that is 7x plus b1y, that is y plus c1, that is plus 3 by under root of a1 square, that is 7 square plus b1 square 1 square equals to plus or minus. So a2x plus b2y plus c2 nothing but plus or minus x minus y plus 1 by here a2 square plus b2 square nothing but 1 under root of 1 square plus minus 1 whole square. After simplification, so we will have that here 7 square equals to 49, 1 square equals to 1, 49 plus 1, 50. Again here 1 square equals to 1 and minus 1 whole square also 1. 1 plus 1 equals to root 2. Again, after simplification, we will get that just we have to write that root 50 as inside the root, we can write it as 50 as 2 into 25. So just I am writing like this, like that only, 2 into 25 and this root is as it is, this right hand side is as it is. Now again we have to simplify. So here by taking this root 25 outside, we will get that 5. So the denominator becomes as 5 root 2 and this is root 2. Remaining terms are same, that is 7x plus y plus 3 by 5 root 2 equals to plus or minus x minus y plus 1 by root 2. So again, by cancelling that root 2 on both sides, root 2 will be cancelled on both sides. We will have that next step as 7x plus y plus 3 by 5 equals to plus or minus x minus y plus 1 by 1. Nothing but plus or minus x minus y plus 1. So after cross multiplication, so we will have that is 7x plus y plus 3 equals to 5 plus or minus 5 into x minus y plus 1. Again, after simplification means we have to multiply all the terms x minus y plus 1 with 5. So we will have that is here we are taking that plus or minus symbol means what? First of all, we have to take that plus symbol. After that, we have to take that minus symbol. So that equals to 7x plus y plus 3 equals to 5 into x minus y plus 1. And we will get that by taking that another symbol, that is 7x plus y plus 3 equals to minus 5 into x minus y plus 1. So here also once again we have to simplify. So that is nothing but 7x, here 5 into x is 5x. By taking this left hand side, we will get that 7x minus 5x. Again, that is nothing but 7x plus y plus 3 minus 5x minus or minus plus 5y minus 5 equal to 0. After simplifying this second one also, we will get that 7x plus y plus 3. Here minus or minus means plus 5x. Here plus, that is minus 5y. Again here plus 5 equal to 0. Again after simplification, so we will have that here 7x minus 5x, that equals to 2x, y plus 5y 6y and 3 minus 5 minus 2, and here 7x plus 5x, 7 plus 5 12x, again y minus 5 1y minus 5y, that is minus 4y plus 3 plus 5, that is plus 8. So here also, so we have to write that first equation as by taking that 2 as common from all these terms. So that is 2 into x plus 3y minus 1 equal to 0. And so from this second equation, we can take that 4 as common from all these three terms. That is 4 into 3x minus y plus 2 equal to 0. Here we got that first line as 2 into something equal to 0 and second line as 4 into something equal to minus 1. So we can cancel that 2 and 4 from these two equations. So we will get the required equations, or that is those are the angle bisectors of the given two straight lines. So that is 7x plus y plus 3 equal to 0 and x minus y plus 1 equal to 0 are what are those? So those are x plus 3y minus 1 equal to 0 and 3x minus y plus 2 equal to 0. Now here we will get the two equations of two straight lines. Two equations of straight lines. So here two equation means, so we will get that one straight line will be the acute angle bisector and another line will be the obtuse angle bisector. So this first line may be obtuse angle bisector or acute angle bisector. So for at last we will get the these two will be the both the angle bisectors of both the angles. So let us discuss about that one more theorem, that is pair of bisectors of the angles between the pair of straight lines. By using this previous theorem, we are going to prove that is pair of bisectors of the angle between the given pair of straight lines. Here the theorem is, if the equation ax square plus 2hxy plus by square equal to 0 represents a pair of intersecting lines, then the combined equation of pair of bisectors of the angles between the given lines, that is ax square plus 2hx square plus by square equal to 0 is h into x square minus y square equals to a minus b into xy. Now we are going to prove this theorem by using the previous theorem, by taking the equations of the bisectors of the angles individually. Now after taking that, so we have to write we will get the combined equation of those two bisectors. So according to this diagram, just see here. So these red lines are given pair of straight lines, and that so from this pair of straight lines we will have the two types of angles. Two types of angles. So one smaller angle is the acute angle bisector and bigger angle will be the obtuse angle bisectors. So here let us take here according to that previous theorem. So this equation ax square plus 2hx square plus by square equal to 0 represents the pair of straight lines which is passing through the origin. So if and only if x square greater than or equal to ab, nothing but, so this is passing through the this is the equation of the pair of straight lines which is passing through the origin. Now we have to take two straight lines which represent the given pair of straight lines individually. So we are taking that those two straight lines in the symmetric form. Suppose here the equation of the straight line which is passing through the origin will be of the form of y equal to mx. So but we know that m is nothing but m is the slope of the equation of slope of the straight line. So therefore m is nothing but m equals to tan theta, where theta is a straight angle which makes the straight line with the positive direction of the x-axis. Therefore y equals to mx. In place of mx we can write that tan theta into x. Again this tan theta can be written as sin theta by cos theta or sin alpha by cos alpha. So y equal to sin alpha by cos alpha into x is there. After cross multiplication we will get the straight line will be of the form of like this. If we take that angle is alpha, we will get that symmetric form as, that is L1 equals to x sin alpha minus y cos alpha equal to 0, and that L2 as x sin beta minus y cos beta equal to 0. Now we are taking two straight lines which represent the given pair of straight lines. Now after taking these two straight lines, again we have to write the combined equation of those two straight lines. Now that is ax square plus 2hx square plus by square equal to x sin alpha minus y cos alpha into x sin beta minus y cos beta. Now we have to multiply these two straight lines, these two equations. So therefore x sin alpha into x sin beta, nothing but x square sin alpha sin beta. Again x sin alpha into minus y cos beta, that is minus xy sin alpha cos beta. Again minus cos alpha into x sin beta, plus in minus, that is xy cos alpha sin beta, cos alpha sin beta. At last, that is minus y cos alpha into minus y cos beta, that is minus into minus plus y square cos alpha cos beta. So again we have to simplify the right hand side. So in this case, we will get that one x square term and two xy terms and one y square term. Now writing these two xy terms at one place and taking that minus xy as common. That is x square into sin alpha sin beta is as it is. Next, from these two steps we can write that minus xy into sin alpha cos beta plus cos alpha sin beta plus y square cos alpha cos beta. Now here, so but we know that, so this expansion, already we know this expansion in our 10th class or in our first year also. So there is one trigonometric identity. It is in the form of sin A cos B plus cos A sin B, which is nothing but sin of A plus B expansion. So alpha is in place of A and beta is in place of B. So therefore, so we have to write the, again rewrite the equation that right hand side, that is x square sin alpha sin beta minus xy into, this is sin of alpha plus beta plus y square into cos alpha cos beta. Now we have to equate on both sides. Therefore, we got that LHS equal to this much. If these two equations are same, means what, we have to equate the coefficients of the like terms on both sides. So therefore, here that left hand side is that is in the form of ax square plus 2hx square plus by square. Here also it is in the form of ax square plus 2hxy plus by square. Now comparing on both sides, we will have that quotient of x square is, what is that? Here x square quotient is sin alpha sin beta from the right hand side, that is sin alpha sin beta equal to left hand side is a, that is sin alpha sin beta equal to a. Again that sin of alpha plus beta equals to, here minus sin of alpha plus beta equals to 2h is there. Now we can write it as plus sin of alpha plus beta equals to minus 2h. Next, that y square coefficient, that is cos alpha cos beta equals to, that is b, cos alpha cos beta equal to b. Now we will use this three terms in later. So from the previous theorem, already we just now we have discussed that, that is equations of the angle bisectors of the given two straight lines. So from the previous theorem, we have discussed that the equations of the angle bisectors of the straight lines, L1 equals to a1x plus b1y equal to 0 and L2 equal to a2x plus b2y equal to 0 are of the form of a1x plus b1y by under root of a1 square plus b1 square equals to plus or minus a2x plus b2y by under root of a2 square plus b2 square. So here those two lines are passing through the origin. Here also we are taking that this line also passing through the origin. Next, now we are going to find the equations of the angle bisectors of these two straight lines. Now this first straight line is of the form of a1x plus b1y equal to 0. This second straight line is of the form of a2x plus b2y equal to 0. Now writing the equations of the angle bisectors. So that equals to, so modulus, here these two terms are what is nothing but these are perpendicular distances are equal. So nothing but here we will get that here we will get that modulus of x sin alpha minus y cos alpha by here sin alpha whole square plus here minus cos alpha whole square equals to modulus of x sin beta minus y cos beta by under root of sin beta whole square plus minus cos beta whole square. Here now After simplification of the denominators, here the denominators of the form of sin square theta plus cos square theta. That is nothing but sin square a plus r square a equals to 1. So denominator will be 1. So here we will get that modulus of x sin alpha minus y cos alpha equal to modulus of x sin beta minus y cos beta by 1. Here no need to writing that 1. Again, to remove this, as we have discussed that to remove the modulus symbol from those two terms, we have to put the plus or minus symbol to that right hand side term. That is nothing but x sin alpha minus y cos alpha equal to plus or minus x sin beta minus y cos beta. Now here, after getting this step, just we have to square on both sides, squaring on both sides, and we have to bring this right hand side term towards that left hand side. That is squaring on both sides and simplifying. So we will have that x sin alpha minus y cos alpha whole square minus this whole square, that is minus x sin beta minus y cos beta whole square. Now here each term, each expansion is of the form of a minus b whole square. It is also in the form of a minus b whole square. We know the expansion, that the terms in the expansion a minus b whole square are a square plus b square minus 2ab. Here also we will get that x sin alpha whole square plus minus y cos alpha whole square minus 2ab term minus 2xy, that is minus x sin alpha minus 2 into x sin alpha into y cos alpha, nothing but minus 2xy sin alpha cos alpha. Similarly, minus here x sin beta whole square plus minus y cos beta whole square minus 2ab term. Here minus symbol is there, minus 2xy sin beta cos beta equals to 0. Again we have to simplify. That is x sin alpha whole square, nothing but x square sin square alpha. Again minus y cos alpha whole square equals to y square cos square alpha. Next here, just I am writing that minus 2xy sin alpha cos alpha. In the next step, I am going to write that minus xy into 2 sin alpha cos alpha. So here that minus x square sin square beta plus y square cos square beta minus 2xy sin beta cos beta equal to 0. Now here we have to change that is x square sin square alpha plus, just see that previous step, that is x square sin square alpha. Now here I am taking that x square term, that is x square into sin square alpha minus sin square beta, that is x square sin square alpha minus x square sin square beta. Similarly, if you take that y square as common, y square into cos square alpha minus cos square beta, like this. So just see the step, that is x square sin square alpha plus y square cos square alpha minus xy into sin 2 alpha here. So we got that it is in the form of 2 sin alpha cos alpha, that is sin 2 alpha minus x square sin square. These are the terms in the second expansion. These are the terms in the first expansion. So only changes only sin 2 beta, and here we got that sin 2 alpha. Remaining steps are same. Now here, now I am taking that x square as common from these two steps, these two expansions, x square into sin square alpha and minus x square into sin square beta. From these two terms I am taking that x square as common, that is plus sin square alpha minus sin square beta. Again from these two terms I am taking that plus y square as common, that is cos square alpha minus cos square beta. Next from these two steps I am taking that minus xy as common, that is sin 2 alpha plus sin 2 alpha, again that minus sin 2 beta. So here again, so this first step is as it is I am writing. So but here this second step, just we have to change in terms of sign terms according to that trigonometric identity, that is cos square alpha plus cos square alpha plus sin square alpha equals to 1 equals to cos square alpha plus sin square alpha equal to 1, nothing but cos square alpha can be written as 1 minus sin square alpha. So therefore in place of cos square alpha I am writing that 1 minus sin square alpha, again minus, again I am writing that cos square beta in terms of sin square beta terms, that is minus of minus 1 plus sin square beta, that is minus of 1 minus sin square beta, nothing but minus 1 plus sin square beta, that is minus xy into sin 2 alpha minus sin 2 beta. Now here, so in the above step, just we can cancel that -1 and +1 will be cancelled. Remaining steps are that is x square into now that is x square sine square alpha minus sine square beta here plus y square into minus sine square alpha plus sine square beta into minus xy into sine 2 alpha minus sine 2 beta. So here, so from these two steps again I am taking that x square minus here. So here we have to take that minus as common from these two steps. So that is minus y square into sine square alpha minus sine square beta. So in this case, we will get the same steps. That is here x square into sine square alpha minus sine square beta minus y square into sine square alpha minus sine square beta also. So from these two steps, I am taking that sine square alpha minus sine square beta as common. We will have that x square minus y square. Again that minus xy into sine 2 alpha minus sine 2 beta. So here we have to split by using the identities, trigonometric identities, that is sine square alpha minus sine square beta. Now these two terms are of the form of sine square a minus sine square b. Again these two are of the form of sine c minus sine d. So we have to use this, we have to change this step by using the transformations, and this step using the trigonometric identities, that is sine square alpha minus sine square beta, nothing but sine of alpha plus beta into sine of alpha minus beta. Again this step is of the form of sine c minus sine d, that is minus, that is plus 2 cos c plus d by 2, sorry. So minus xy into 2 cos c plus d by 2, that is 2 alpha plus 2 beta by 2, that is 2 into alpha plus beta by 2. 2 will be cancelled, that is 2 cos of alpha plus beta. Again that sine of alpha minus beta, nothing but 2 alpha minus 2 beta by 2. 2 into alpha minus beta by 2. 2 to cancel, we will get that sine of alpha minus beta equal to 0. Just by observing these two steps, we will have that sine of alpha minus beta is common for the both the steps. So therefore from total equation I am going to take that sine of alpha plus beta as common from all these terms. So here we can write the step sine of alpha minus beta equals to into x square minus y square into sine of alpha plus beta minus 2xy into cos of alpha plus beta equal to 0. Here also we got that product of these two terms, product of sine of alpha minus beta and this total bracket equal to 0 means what? Here we can equate either of these two. We can equate this first term equals to 0 and second term also 0. But here if we equate that sine of alpha minus beta equal to 0, here, so we know that sine 0 equal to 0, that's why here alpha minus beta equal to 0. But here if alpha minus beta equal to 0, alpha will be equals to beta. But here alpha and beta are two different angles. That's why we should not take this sine of alpha minus beta equal to 0. We have, that is sine of alpha minus beta is not equal to 0. We have to equate the remaining part, that is x square minus y square into sine of alpha plus beta minus 2xy into cos of alpha plus beta equals to 0. So that is x square minus y square into sine of alpha plus beta minus 2xy into 1. Now I am expanding this cos of alpha plus beta in the form of cos of a plus b, as we discussed in our trigonometry part. That is, it is of the form of cos of a plus b. That is cos a plus b. That expansion in the terms of cos of a plus b as cos a cos b minus sin a sin b. So this cos expansion is different from that sin expansion. So in the sin expansion, inside the bracket, suppose plus is there, in the expansion also we will get that plus symbol between those two terms. But instead of that plus symbol, here we will get that minus symbol. Therefore here cos of alpha plus beta equals to cos alpha cos beta minus sin alpha sin beta equals to 0. Now here but already we got the condition sin alpha sin beta equals to a, and that cos alpha cos beta equal to b, and that sin of alpha plus beta equals to minus 2h. So rewriting that, substituting that in above condition or above equation. So that is, instead of that sin of alpha plus beta, now I am substituting that minus 2h, that is minus 2xy into Here this value is B and this value is sin A alpha, sin beta is A. Now again we have to rewrite the equation, that is minus 2h into something means, that is this thing means we have to write that minus 2h as in the beginning one, minus 2h into x square minus y square. Here I am taking that minus I come again from these two terms, that is minus into minus plus 2xy into here a minus b equal to 0. Here from these two terms, that is again we have to take that minus 2 as common. So we will have that is minus 2 into h into x square minus y square minus xy into a minus b equal to 0. So therefore the equation of the pair of angle bisectors of the given pair of straight lines is, that is h into x square minus y square minus xy into a minus b equal to 0, or h into x square minus y square equals to xy into a minus b. Therefore the equation of the, that is combined equation of the pair of angle bisector of the given pair of straight lines ax square plus 2hxy plus by square equal to 0 is h into x square minus y square equals to xy into a minus b. Now by using this formula, now we are going to find the pair of angle bisectors of the given pair of straight lines. So here we have to find out the combined equation of the pair of bisectors of the angles between the pair of straight lines represented by 6x square plus 11x square plus 3y square equal to 0. Here first of all we have to write the given equation is 6x square plus 11x square plus 3y square equal to 0, and we have to compare this equation with the equation ax square plus 2hx square plus by square equal to 0. Now here we can write that ax square, that is a equal to 6 and that 2h equals to 11 and b equal to 3. Now we have to substitute this a, b and 2h values in our formula. Just now we have obtained that formula, that is pair of angle bisectors. So that is in the formula h into x square minus y square equals to a minus b into xy. Just we have to substitute the values h and a and b. So here from this 2h equals to 11, h will be 11 by 2. Therefore that h into x square minus y square nothing but 11 by 2 into x square minus y square equals to a minus b 6 minus 3 into xy. After simplifying this step, we'll have that 11 by 2 into x square minus y square equals to 6 minus 3, 3xy. Now from the cross multiplication, we will have that 11 into x square minus y square equal to 2 into 3, 6xy. Again after just arranging the terms in a order, that is 11x square plus 11x square minus 6xy minus 11y square equal to 0. This is the equation of the pair of angle bisectors of the given pair of straight lines 6x square plus 11xy plus 3y square equal to 0. Now let us solve one problem, that is product of the perpendiculars. So the product of the perpendicular distances from a point P alpha comma beta to the pair of straight lines ax square plus 2hxy plus by square equal to 0 is modulus of a alpha square plus 2h alpha beta plus b beta square by under root of a minus b whole square plus 4h square. So just see from the above figure. So here, so these two are two straight lines which are represent the given pair of straight lines to ax square plus 2hx square plus by square equal to 0. Now I am taking two straight lines individually which are passing to the origin, and that suppose here given that p alpha comma beta point is given. Now here p is the position of the point, that is alpha comma beta. Now here the perpendicular distances from the P point to that first line, and that second line is, first line is what is that PM equals to D1 and that PN equals to D2. Now we have to prove that the product of the perpendicular distances. We have to show that d1 into d2. d1 into d2 equals to this much. Modulus of a alpha square plus 2h alpha beta plus b beta square by under root of a minus b whole square plus 4h square. Now here, given the equation of the pair of straight lines is ax square plus 2hx square plus by square equal to 0. Let us represent the equation as 1. Now, let the equation 1 represents two individual lines which are passing through the origin. Now, I am taking those two straight lines individually. Those are L1x plus M1y equal to 0 and that L2x plus M2y equal to 0. Now, we have to write the combined equation of those two straight lines. So that equals to ax square plus 2hx square plus by square equals to L1x plus M1y into L2x plus M2y. Now after writing that, just we have to simplify. Already we know this. These two terms, x squared and xy and y squared terms will be there. Already we got that while finding the angle between the given pair of straight lines cos theta, while finding the cos theta formula. So we obtained that here. So right hand side will be L1 L2 x square plus L1 M2 plus L2 M1 xy plus M1 M2 y square. Now here equating the coefficients on both sides. So that is here L1 L2 equals to, that is comparing on both sides. L1 L2 equals to L1 L2 equals to A and that L1 M2 plus L2 M1 equals to 2H and that M1 M2 equals to B. Now, as we have just now we have discussed that let D1 comma D2 be the lengths of the perpendiculars. D1 comma D2 be the lengths of the perpendiculars from the point P to that given two straight lines. D1 is the perpendicular distance from the P to that first straight line, that is equation 2, and that P to that is say third line will be that is a D2. That we have to find out that D1 value and D2 value. Already we know that perpendicular distance, that is the length of the perpendicular from the point P x1 comma y1 to the straight line ax plus by plus c equal to 0 is, that is equals to modulus of ax plus by plus c by under root of a square plus b square. Now here the perpendicular distance from the point x comma y. If you take that x1 comma y1, we will get the perpendicular distance as modulus of ax1 plus by1 plus c by under root of a square plus b square. So here also we will get that L1 L2 equal to A, L1 M2 plus L2 M1 equal to 2H, M1 M2 equals to B. So here let us assume that let D1 comma D2 be the lengths of the perpendiculars drawn from the point P to the P alpha comma beta to the those two straight lines 2 comma 3 respectively. So here second line is what is that? That is a L1x plus M1y equal to 0. Now the perpendicular distance will be D1 will be modulus of L1 alpha plus M1 beta. Here alpha comma beta is in place of x1 comma y1. Similarly, D2 will be modulus of L2 alpha plus M2 beta by root of L2 square plus M2 square. Here also, so here we will get that D1 and D2 value like this. After getting that D1 and D2 values, just we have to multiply those two products, those two lengths of the perpendiculars. D1 into D2 equals to, that is modulus of L1 alpha plus M1 beta by under root of L1 square plus M1 square into modulus of L2 alpha plus M2 beta by under root of L2 square plus M2 square. Now here we have to write these two numerators at one place and in the numerator portion, and that these two denominator values in the denominator part and under a single square root symbol, that is under root of here L1 square plus M1 square into L2 square plus M2 square. Now after simplification, just see here L1 alpha into L2 alpha, that is L1 L2 alpha square, L1 alpha into M2 beta, L1 M2 alpha beta, again that M1 beta into L2 alpha, that is L2 M1 alpha beta. Already just know we got this same step while finding the cos theta formula also. That's why we will get the same step, that is M1 M2 beta square. Here in the denominator also we will get the same, that is L1 L2 whole square plus, that is next to L1 M2 whole square, next to M1 L2 whole square, that is L2 M1 whole square, M1 square M2 square, nothing but M1 M2 whole square. Now here, so in the denominator, just I am adding and subtracting. That is 2L1, L2, M1, M2. While subtracting, I am writing in the same order. That is 2L1, L2, M1, M2. While adding, just I am just changing their places, but the terms, part of those, all the terms will be same. So except that symbol, that is 2 L1, L2 is there, M1, M2 is there, but I am writing as that first term as L2, L1, M2 and second term as L2, M1. Now here just I am adding that same term 2 L1, L2, M1, M2 in the denominator part, adding and subtracting. So now we have to rewrite the step. So just see here. So in this case, so from that we will get that L1, L2 whole square plus L1, M2 whole square here. So we have to write that first L1 L2 whole square and that M1 M2 whole square minus 2 L1 M2 L1 L2 M1 M2 from these three terms. So these three terms of the form of a square plus b square minus 2ab, nothing but a, that is the expansion, the terms of the expansion a minus b whole square, which is nothing but L1 L2 is in place of a and in place of b is M1 M2, that is L1 M2 minus M1 M2 whole square. So plus here from the remaining terms, that is here a square plus b square plus 2ab. Again, these terms are the form of a plus b whole square expansion. That is in place of a, that is L1 M2 is there. In place of b, L2 M1 is there. Nothing but L1 M2 plus L2 M1 whole square. Now we have to simplify. We have to substitute the values of L1 L2 equals to a and that L1 M2 plus L2 M1 equals to 2H and M1 M2 equals to b. Again, this is a minus b whole square. This total term is 2h part. That is L1 M2 plus L2 M1 equal to 2h. That is 2h whole square. So just by writing that one, that is modulus of a alpha square plus 2h alpha beta plus b beta square by under root of a minus b whole square plus here this part is 2h whole square. Again after simplification, we will get one more step. Modulus of a alpha square plus 2h alpha beta plus b beta square by under root of a minus b whole square plus 4h square. So this is the equation of the, this is the product of the lengths of the perpendiculars drawn from the point P alpha comma beta to the given pair of straight lines. So let us solve one problem by using this previous theorem. That is, we have to find the product of the perpendiculars drawn from the point 2 comma minus 1 to the pair of straight lines x square minus 3xy plus 2y square equal to 0. So here given the equation pair of straight lines is x square minus 3xy plus 2y square equal to 0. Let us indicate this line as 1 and given point is P is 2 comma minus 1. This is alpha comma beta. Already we have that formula according to that previous theorem. We have that the product of the perpendicular distances drawn from the point P alpha comma beta to the pair of straight lines ax square plus 2h square plus b square equal to 0 is modulus of a alpha square plus 2h alpha beta plus b beta square by root of a minus b whole square plus 4h square. So here just substituting the values. So we will have that, that is now comparing this given equation with the our pair of straight lines equation with ax square plus 2h square plus by square equal to 0 is here a value equals to 1 and 2h equals to minus 3 and b equals to plus 2. Now substituting and alpha comma beta value is 2 comma 1 minus 1. Now substituting all these 5 values in our formula, that is modulus of a alpha square plus 2h alpha beta plus b beta square by under root of a minus b whole square plus 4h square. Now here we can write that is a alpha square 1 into alpha, that is 2 square plus b beta that is plus 2h alpha beta. We can write that 2h equals to minus 3 plus 2h alpha beta plus b beta square, that is plus 2 into beta square, that is minus 1 whole square by under root of a minus b whole square, that is 1 minus 2 whole square plus, that is 4h square can be written as directly, this is 2, it is a square of the 2h term. We can write that direct writing that my 2h into whole square, 2h whole power 2, it is minus 3 whole square. After simplification, we can write that is 2 square is 4, 4 into 1 4, that is after simplification these three terms 6, and that is minus 1 square is 1, 1 into 2 2, that is here 1 minus 2 is minus 1, minus 1 square is equals to plus 1, minus 2 whole square equals to plus 9, that is 4 plus 6 minus of 4 plus 6 plus 2 by 1 root of 1 plus 9. So after simplifying that, we will have that is modulus of plus 12 by root 10. So here modulus of plus 12 nothing but that is plus 12 only. That is plus 12 by root 10 units. That is the product of the lengths of the perpendiculars drawn from the point 2 comma 1 to a given pair of straight lines x square minus 3x square plus 2y square equal to 0. Now let us discuss about the area of the triangle. The area of the triangle formed by the lines ax square plus 2x square plus by square equal to 0 and lx plus my plus n equal to 0. Here, so in this equation, this equation contains two straight lines and this equation contains one straight line. So totally there are three straight lines. So therefore, from these three straight lines, we will have a triangle, and we have to show that the area of the triangle which is formed by those three lines is, that is modulus of n square into under root of h square minus ab by am square minus 2hlm plus bl square units. Just we have to prove that is the area of that triangle will be that much. Here, let us take that given equation of the pair of straight lines are ax square plus 2h square plus by square equal to 0, and that this is one pair of straight line, and one more straight line also is given, that is lx plus my plus n equal to 0 is given. Again here let us assume that this pair of straight line, this equation represents the two pair of two individual lines respectively, that is OA and OB be the pair of straight lines which is passing through the origin. So that represents that first equation. Again, if this is a pair of straight lines, I am taking two individual straight lines OA and OB which represents the given equation 1. Let us take that OA equal to L1x plus M1y equal to 0 and that OB as L2x plus M2y equal to 0. Here we have to name them as this is first equation, second equation and third equation. So here again, given that another line is, that is lx plus my plus n equal to 0. No, just see the figure. So this is OA side and this is OB side, and this is given individual line, that is lx plus my plus n equal to 0. This is a fourth equation. So now from these three sides, so we get a triangle, and we have to find out the area of the triangle found by those three sides. So here again we have to write the combined equation as it is. So we will get the right hand side will be like this only. So comparing on both sides, we will get the same thing. L1 L2 equals to A and L1 M2 plus L2 M1 equal to 2H. Next to M1 M2 equals to B, as we solve so many times. So therefore clearly the here already we know that the equation ax square plus 2h square plus by square equal to 0, that represents that OA and OB line, that is second and third lines. The point of intersection of those two lines will be, what is that, 0 comma 0, that is nothing but origin. We know that clearly the point of intersection of the second and third lines is origin. Now let us find that we have to find out the remaining two vertices. So just see here. In this case, we have to find out the area of the triangle OAB. Already we know that O is a point of intersection of these two straight lines. O is origin. Now, what is our duty? It is, we have to find out the A and B vertices. Here, A vertex is the point of intersection of second and fourth sides, and that B is the point of intersection of third and fourth sides. So therefore, now let us find that A vertex. Let the point of intersection of second and fourth is A x1 comma y1. So second and fourth means what? Second equation is L1 x1 plus M1 y1 equal to 0. Because we are taking that A x1 comma y1 is y1 lies on the given two straight lines. Therefore, we have to substitute. We have to write that second equation as L1x1 plus M1y1 equal to 0, and say next fourth equation as Lx1 plus My1 plus N equal to 0. As we have solved in the geometry part, so finding the point of intersection of these two straight lines. Now here this first straight line is of the form of a1x plus b1y plus c1 equal to 0, and second straight line is of the form of a2x plus b2y plus c2 equal to 0. Now we can write that. So x1 by here b1 c2, b1 c2, that is b1 equals to m1, c2 equals to n, m1 n, b1 c2 minus b2 c1, m into, here in this case c1 will be 0, constant term will be 0, that is m into 0 is nothing but 0, that is m1n minus 0, nothing but m1n. Similarly y1 by, that is c1a2 minus c2a1, c1 equal to what is that, 0, 0 into l, 0 minus c2a1 minus, that is c2 equal to n into l1, n l1 or minus l1 n. So that is y1 by, that is that is c1a2 minus c2a1, that is equals to 1 by a1 b2 minus a2 b1, a1 equals to l1 b1 a1 b2 l1 m minus lm1, l1 m minus lm1. So now by taking that, to get that x value we have to equate first and last term. So we will get that x1 value equals to, by taking this that right hand side becomes as the numerator, that is m1n by this thing l1m minus lm1. Similarly by equating these two terms we will get that y1 equals to minus l1n by l1m minus lm1. So we got that a x1 comma y1, that is first vertex a equals to, we got that m1n by l1m minus lm1 comma minus l1n by l1m minus lm1. Similarly, the point of intersection of that third and fourth also, what is that, b vertex. So we got that a vertex like this. Similarly b vertex. So how can we get that b vertex? Only change that, instead of that 1 we have to put that 2 symbol in that b, that is b x2 comma y2, nothing but that is b equals to m2n by l2m minus lm2 comma minus L2n by L2m minus LM2. So in place of one number we have to put 2 symbol, that is we will get the this b value. Already we know that origin equal to 0 0. Now we have that 3 vertices a b c. So here now let us assume that, so this value as x1 comma y1, this is x2 comma y2, and this is 0 comma 0. We have a direct formula of the triangle OAB. One of the vertex is origin and remaining two vertices are a x1 y1 and b x2 y2. Then we have the area of the triangle is half into modulus of x1 y2 minus x2 y1. So we will get that we have to use that formula, half into modulus of x1 y2 minus x2 y1 square units. Now let us substitute the values, that is half into x1 y2. Just see here, this is x1 and this is y2. Now we have to multiply these two things, that is, so m1n into minus l2n. From these two things n into n means what, n square will be there. We will get that minus symbol, that is minus n square into m1 n2. Here in the denominator we will get the product of these two things. Again we will get that minus symbol to this first term. Again minus x2 y1, minus x2 y1 means while writing multiplying these two things will already they have that minus symbol, we will get that plus symbol. So that's why for this step we will get that plus symbol. That's why I am writing this step as first step. So from these two terms we will have that n square into L1 M2. So from those two terms we can take that n square as common, that is n square into L1 M2 minus L2 M1 by product of these two things, L1 M minus LM1 into L2 M minus LM2 square units. Again we have to simplify. So just see here. So now instead of that L1 M2 minus L2 M1 we have to, now it is in the form of A minus B. A minus B nothing but under root of a plus b whole square minus 4ab. So now writing the on the step we will get that. So that is n square into, so this is nothing but L1 M2 plus L2 M1. This is A minus B, nothing but under root of A plus B whole square minus 4AB. While writing that AB, instead of writing that L1 M2 L2 M1, just I am writing that both the LC at one place and both the MC at another place. That is minus 4 L1 L2 L M1 M2. Again here, if we simplify the denominator, L1M into L2M, L1 L2M square. Similarly, L1M into minus LM2. In this case, so the terms having the numbers are, what are those? L1 and M2. That is L1 M2 here minus LM. That is minus, taking that minus LM as common, that is L1 M2. Similarly, by multiplying these two terms, we will get that minus LM into, that is L2 M1, L2 M1. So again, by multiplying these last two terms, that is minus LM1 and minus LM2, that is minus into minus plus, that is M1 M2 L square. After simplification, so we will have that. Already we know that this L1 M2 plus L2 M1 equals to 2H. Next to, again here L1 L2 equals to A, M1 M2 equals to B. Now substitute the values. We will have that n square into under root of, here this is 2H whole square. 2H whole square means we will get that 4H square. That is 4AC, 4AB, 4AB by, this is A M square minus, this is 2H minus 2HLM plus BL square, BL square, square units. So therefore we got the area of the triangle. Now here let us just simplify this above step here. By taking that 4 as common from these two terms, we will get that 4 into H square minus AB. After taking that 4 as common, just we have to take 4 outside, it becomes as 2. This 2 and this denominator 2 will be get cancelled. We will have the remaining terms are n square into under root of H square minus AB modulus. This modulus symbol will be for the denominator part only. It is not necessary for the numerator part. Already these two terms will be positive. So therefore modulus of AM square minus 2HLM plus BL square, square units. That is the area of the triangle formed by the given three straight lines. Now let us find the area of the triangle formed by the three lines. So first one is pair of straight line and second one is straight line.
Srinivas sir?
Straight lines are. So let us assume
Srinivas
that.
Sir, you please give the slide and ask them to take the screenshot. We will give it as a practice for the students.
Okay.
Okay.
Take the screenshot. Dear students,
the solution is already given. They can take the screenshot and practice themselves. Wait
just
for a while.
Screenshot of this screen.
Children, please take the screenshot. And sir has given you a few problems. You can copy, take a screenshot and practice them.
So dear children, just try these problems. So these three problems will be solved by using our, already just now only we have discussed the formulae. So just try them. Thank you children. Thank you madam.
Thank you so much, Srinivas sir.
Thank you very
much. It was a detailed explanation and wonderful presentation. I'm sure students will do that last problem as well as the 3 questions that you have given them for practice work. Students, only when you practice those questions, you will be able to really get a hold on the concept. So I request you to surely solve all those problems, and if you have any queries, any doubts, you can ask your subject teachers at the school level. Your teachers will be happy to clarify those doubts also. You can as well type them in the chat box. We will definitely try to answer them in the next session. Thank you, Srinivas Garu. Thank you so much.
Thank you, madam. Thank you very much.